All right, ladies and gentlemen, welcome back to example 2. We're still talking about permutations, but there's a formula. And I want to show we actually could have used the formula on the last example. So I'm going to switch back to example 1. Over here on the right, I actually worked through to show you we would get the same answer given this formula. So I use this because I want to try to make it clear how it works. If we remember back to example 1, we were supposed to use 4 letters from a 4-letter word in any combination that we could. That means in our formula in PR, N stands for how many total letters are we using in this case. R is how many are we, how many do we have is in how many are we using is R. We have 4 letters and we're using 4 letters, so that means our notation is 4P4. Now, that's the same thing as 4 factorial. But on example B, we have NPR, where N is we have 4 letters, R is we're using 2 of them, so our notation becomes 4P2. And that's going to be equal to N factorial over N minus R quantity factorial. That's what we see here. Forgot one highlight. Boom. All right. So in this case, we're talking about there's 10 horses running in a race. And how many different ways can the horses finish first, second, and third? In other words, we're not going to be taking into account all 10 places. We're only going to be taking 10, but there's 10, sorry, not 10 races, all 10. We're not going to say first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. We're only worried about 1, 2, and 3, first, second, third. There we go. So one way to read the formula of NPR is not just NPR, it's out of 4 choices or objects. The probability of those objects achieving R outcomes is. So in this case, out of 10 horses, so 10 is going to be equal to our N, the probability of 3, or the first 3 places being any of those 10 horses, is equal to that same 10 with a factorial divided by 10 minus 3 factorial. So the only items I'm actually putting in are those 10 and the 3. And when I do that, I'm going to find that 10 factorial I don't want to process yet. I'm going to show you why. So it's going to stay the same. But 10 minus 3 I do want to process. That's going to be 7, and I'm left with that factorial. Now 10 factorial is the same thing. Now I want to get it where I have the same factorial in the numerator and denominator, because remember, when we have the same factor, they cancel. Well, 7 factorial is a factor here because 10 is bigger than 7. If it was less than, we'd do some other things. We'd actually be doing what I'm doing in the numerator and the denominator. If the denominator is bigger, wherever it's bigger, we need to write it as 10 times 9 times 8 times, and now the next number is going to be the same as the denominator, so I can just write 7 factorial. The reason I want to do that, again, is when I have the same factor in the numerator and the denominator, it's the same thing as itself divided by itself, creating 1, and anything over, which means a 1 is left here. Anything multiplied by 1 is itself. Anything divided by 1 is itself. So that means if I find the answer to 10 times 9 times 8, it will be the same answer as 10 factorial over 10 minus 3 quantity factorial. So 9 times 8 is 72. 72 times 10 is 700 720. So given 10 horses, in a race, there are 720 possibilities of who would be first, who would be second, and who would be third.